Example 2. A plant food that is 9% nitrogen must be combined with another plant food that is 25% nitrogen to make 10 gallons of a solution that is 15% nitrogen. How many gallons of each should be used to obtain the desired solution? So draw out your circles. We're going to put our percents at the top and our amounts at the bottom. So percents, we're adding a, what is this, a 9% with another one that's 25%. Okay, that's those two. And we want to make 10 gallons of a 15%. Oh, that looks good, the 15% at the end. It's right in between these first two. And then the 10 gallons, which one does that go with? The 25% or the 15? 10 gallons, that is 15%. So right over here, 10 gallons. Case 1, case 2, or case 3? Right, case 3. We know that the total, but we don't know each of the first two. So in that case, the first one's going to be x, and the second one is going to be the total minus x. In this case, 10 minus x. Now we'll go right to our equation. Multiply these two plus the product of these two equals the product of these two. Now we didn't bother changing them to decimals. Distribute the 25, multiply these two numbers, add the like terms. A 9x and a negative 25x is negative 16x. Then move over the 250. And don't forget to bring down the negative here with the 16. So we get x equals a positive. That was important to make sure that we didn't mess up with our signs here. This number has to be positive. If you end up with a negative, that tells you right away it can't be right. You can't have a negative quantity. So 6.25. So that's 6.25 gallons of the 9% nitrogen plant food. And then what about this one, the 25%? Well, it's 10 minus x. X is 6.25. So 10 minus 6.25 is 3.75. If you wrote these with mixed numbers, that would be fine too. This would be 6 1/4, 3 3/4. That's fine. So now we can answer our question. 6.25 gallons of the 9% nitrogen plant food and 3.75 gallons of the 25% nitrogen plant food. Okay, we'll go on to the next example. Example 3. If 10 grams of pure silver are added to 40 grams of a 50% silver alloy, what is the percent of silver in the resulting alloy? Well, let's put the information that we know. 10 grams of a pure silver, pure, interesting. 40 grams, that's 50%. So this one is 50% silver. Now we're adding a pure silver, so what percent silver is pure? 100, right. Now for our final circle, what is the percent of silver in the resulting alloy? That's what we're trying to find. And how many grams are we going to have at the end? Alright, well this is case 1, so we have the two quantities, so we add them. That would be 50, and then this will be our x, the percent of silver in the resulting alloy. Okay, so that one was 100% because it was pure silver. These percents have to match up. Now, when we're all done, what do we know about this final percent here? Can it be less than 50? No. It has to be somewhere between 50 and 100. Somewhere in between those two. Just kind of something to start thinking about to make sure when we're done, we can feel confident with our answer. Let's go to the equation. Multiply these two plus the product of these two equals the product of these two. Multiply that, that's 1,000. 5 times 4 is 20, and then add the two zeros. So 1,000 plus 2,000 is 3,000, divide both sides by 50, and we get 60. Is that grams or is that a percent? Well, it's up here with a percent, so that's a percent. The percent of silver in the resulting alloy is 60%. Does that sound right? 60% in between 100 and 50? Yeah, definitely. So the answer is 60%. All right, one more example. Example 4. How much pure water should be added to 90 liters of a coolant that is 80% antifreeze to obtain a coolant that is 50% antifreeze? Start with the circles. That's our first step. Draw those 3 circles in, and then we'll start putting in the numbers. We're adding water, so this one's water over here, to 90 liters. That's 80%, and we want to end up with a 50% antifreeze. We're adding pure water. Pure is at 100%. Let's put in the 100%. Can that be right? Is this one in between these two? No, that doesn't make any sense, right? Think about these percents over here. 80%. It's 80% antifreeze. And this 50% is 50% antifreeze. Well, this 100%, is that 100% antifreeze? No, it's water. What percent antifreeze is in water? None. So that can't be right. So instead of using 100%, we're going to use 0%. Okay, so whenever we're using a pure substance, it's either going to be 100 or 0. The reason it's 0 in this case is because we're diluting this from an 80% to bring it down to a 50% antifreeze. If you wanted to add pure antifreeze, then if this was antifreeze, then it would be 100%, and that would be to raise it for some reason. So these percents, again, these two, our final has to be in between these two. And this is either a 0 or 100, depending on what it is. They have to all match. They're all percent of antifreeze. This is 0% antifreeze, 80% antifreeze, 50% antifreeze. If we're going to use 100% water, if we used 100 here, this would have to be 100% water, 80% water, and 50% water. Okay, so case 1, case 2, or case 3. Case 2, because we have one of the numbers, which is 90. So the first amount is going to be x, and then our last quantity is going to be x plus 90. Remember, it's addition. Write down our product. Well, this is nice. 0 times x. What's 0 times x? Right, just 0. So that's going to drop out. Distribute on this side. Bring the 4,500 over, so you get 2,700. Then divide by 50, and x is equal to 54. So our answer is there's 54 liters of pure water must be added to obtain a coolant that's 50% antifreeze.